Once again, we're going to use shells to find the volume of the solid that's revolved around the y-axis. We have our x equals 1, which is our vertical line right here. We have our y equals 0, which is our x-axis. And then we have x is equal to y cubed, and that's this curve right here. So we're looking at the region that's bound by all three of those curves, and that's right there. And we're going to go ahead and shade that region. We're going to revolve that around the y-axis right here. When it's a vertical axis of revolution, we need to be dealing with x. So your bounds on your integral are your x's. Starts at 0, goes over to 1, so your bounds are 0 to 1. So it's always 2 pi times your integral with your bounds. Then we need to have in your radius. If we take any point here, we're dealing with x. It's going to be x units over. Our axis of revolution is here at 0. We got to take what's on the right of x minus what's on the left of 0, which is just x. And we can't actually go ahead and do the height part right now, because right now we have y cubed is equal to x, and we need to have y by itself. So if we solve this for y by taking the cube root of both sides, we end up with y equaling the cube root of x. Now let's go ahead and take a look at our height in terms of x's. We got to take what's on top minus what's on the bottom. So we got to go what's on top, which is our function, minus what's on the bottom, which is 0. So we got to go our cube root of x on top minus our 0 on the bottom, or just the cube root of x. Well, that's just an x to the 1/3 times our x in front is really just an x to the 4/3. Then we can go ahead and integrate that, and then we can plug in our 1 minus what you get when you plug in your 0. And we end up getting 6 pi over 7.